Okay, great. Now in the first part, we have already seen that this, smaller sprocket is going to move faster, so that it can catch up with what is happening in the front sprocket. Now we want to find out how fast. So let's just see. So what we are seeing over here is that if you want to find out how fast this is going to move, just understand this, that both these points, point A and point B, are actually connected to the same chain, and which means their velocities are going to be the same. And this is a very important point because this is going to tell us that what is the relationship between theta f and theta r. So what I can say, because VB is VA, I can say that the angular velocity of the front sprocket multiplied by the radius of the front sprocket must be equal to angular velocity. This is nothing but the formula for this tangential point, right? The velocity of this tangential point. So is the case with the velocity of the tangential point over here. Now you just understand that because the radius is smaller, so it has to compensate for that smaller radius by increasing this omega, and that's what we are trying to understand. So overall, this is a pretty simple concept, and ultimately what do we get is that the displacement in the front stroke, the angular displacement in the front sprocket, the ratio of the angular displacement of front sprocket and the angular displacement of rear sprocket is actually the radius of rear sprocket and the radius of front sprocket. So it just reverses, where you have got the theta fs front sprocket, that's where you get the radius of rear sprocket. Anyways, so this was anyways expected. Now what you have to do is, because we in the first part saw that there is an equation which can relate the force of friction and force of pedal, and this is what you get. Now remember, there was an equation over here. This equation, I just brought the force of friction, I kept force of friction here, and I brought this force of pedal as denominator. And what did I find? I find that there is an equation which is something like this. And I've just now found what is the ratio of the angular displacement of front socket and the angular displacement of rear socket, and which is this. So if I put this in equation 2, this new found ratio, which is equation 2, in equation 3, then what do I get? I get the mechanical advantage, because this is what I wanted. This is mechanical advantage. Okay, so now, and this is exactly the same relationship that we got in the part 1. Now, what happens, very interesting thing about this is that this radius of rear sprocket and the ratio of the radius of rear sprocket and the front sprocket is actually called something. And this ratio is called the gear ratio, right? This is called the gear ratio, while the ratio of the radius of pedal and the radius of wheel is called as the crank wheel ratio. So overall, we can write mechanical advantage as crank wheel ratio into gear ratio. Now once again, what is crank wheel ratio? As the name suggests, crank and wheel ratio. So the ratio of the radius of pedal and radius of wheel. And what is the gear ratio? It is the ratio of the output gear, the radius of the rear sprocket, and the ratio of input gear, which is the radius of the front sprocket. This actually has come from the definition, which is the gear ratio is the ratio of angular velocity of input sprocket and angular velocity of output sprocket. So because the angular velocity is inversely proportional to the radius, so this gets reversed. Anyway, so what do we have? Mechanical advantage is crank wheel ratio multiplied by gear ratio. Okay, so now let's try to decode it and let's try to understand what does this mean. So here are our conclusions. Now this basically means that if you have a lower gear ratio, so basically if you have a lower gear, what do I mean by a lower gear? By a lower gear, I mean that this sprocket is going to be very large. As we have seen in bicycles, lower sprocket means that this circle gets large. So you get into a lower gear, and if that happens, that means your rear sprocket, the radius of rear sprocket, actually increases, and this increases. If this increases, then the mechanical advantage increases because this is in the numerator. So if you have a lower gear, then you would have a longer rear sprocket, and that would mean that you have a higher mechanical advantage. Anyways, that is the only thing that you can change, as the front sprocket radius is constant. So if you want to get higher mechanical advantage, you need to go to a lower gear, which means you need to increase the radius of this small circle over here. and that you can do by going to a lower gear. Similarly, mechanical advantage is generally less than 1, and that is because this R pedal upon R wheel is always less than 1. The pedal is always going to have a smaller length than the entire radius of the wheel, so it is always lesser than 1. And this also most of the times is less than 1, because the rear sprocket, this is the rear sprocket circle, it is many a times less smaller than the front sprocket circle. It very rarely becomes larger than the front sprocket circle. When that happens, this becomes greater than 1, but then again, even if this is 1, this is still lesser than 1. So ultimately, what do you get? You might get a value which is smaller than 1. So overall, we generally have a mechanical advantage which is less than 1. Okay, but you can definitely have a mechanical advantage which is greater than 1. What do you need for that? You need a very low gear. Okay, now higher the mechanical advantage, the lower the speed. So if you want good mechanical advantage, you will have to compromise with the slow speed. Anyways, finally, in additional information, the additional information is, if you're riding bicycle and you would find out for the direction of the friction on the front wheel, it has to be opposite to the direction of motion. Because if the bicycle is going in this direction, then the front wheel, which I have not drawn, but let's say the front wheel is over here, then what is going to happen? The bicycle is actually pushing this wheel in the forward direction. And remember, this front wheel is not connected to this chain and anything else, right? So it gets pushed in the front direction. So the friction is going to oppose it, and the friction definitely is going to be in the opposite direction of what the bicycle is trying to do. And one more important point is that because this friction, if this friction does not act in the opposite direction, if it doesn't act in the opposite direction, the bicycle is not going to turn in the right direction, or the tire or the wheel is not going to turn clockwise, because the friction has to act over here. If it doesn't act in this direction, it doesn't turn clockwise, then the cycle can't move. So the good point that we have to understand, or an additional information that we have to see, is that if your bicycle is moving, then the front wheel is always facing a frictional force which is opposite to the direction of motion. So that is it. Thank you.